We are going to discuss a theorem 6.8 onwards in the triangle chapter. Given in a right triangle, the square of the hypotenuse is equal to sum of the squares of the other two sides. So this one is a well-known Pythagoras theorem. So state and prove Pythagoras theorem. As the question means, we need to write in a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. Proof. Construct the triangle. Let the triangle ABC right angle at B. So this one is right angle at B, like that construct. We need to prove the hypotenuse squared. AC squared equal to, that is opposite of 90 degree is AC squared. So AC squared equal to sum of the squares of other two sides. So AB squared plus just BC square. Let us draw BD perpendicular to AC. So just to draw the height of this triangle. Now already we know that the triangles ADB, BDC and ABC are similar by using the previous theorem. So now consider the small triangle and the bigger triangle. So for that, triangle ADB, right angle at D, no. So ADB, similarly ABC. So right angle should be in middle. D is right angle, so it should be middle, and B right angle should be in middle. So find that order carefully. So from this we can write AD divided by AB and AB, that is AB divided by this AC. AD divided by AB, AB divided by AC. Sides are proportional, no? So by using the cross multiplication, AB squared equal to AD into AC. Similarly, consider this triangle BDC and the bigger triangle ABC. For BDC we have the same thing, BC divided by BC divided by AZ and CD divided by BC. So anyway we can write anything. Why we need BC? Because we need to prove AB squared plus BC squared. For that we can write things BD divided by AB equal to BC divided by DC divided by DC divided by BC equal to CB divided by CA. BC occur here now, so just to choose this thing. So by using the cross multiplication, BC squared equal to CD into AC. Right. Now just add both the things. So from this we can get AZ is common. Take outside AD plus CD. Just AD plus CD is nothing but AC, total length. Substitute. So AC into AC, that is AC square. So now AC squared equal to AB squared plus BC square. So the above theorem is the naming theorem. It's a Pythagoras theorem. So prove like that. Next problem is the converse of a Pythagoras theorem. So that things we proved, no, that side squared equal to sum of the squares of side squared equal to hypotenuse square. We need to prove this by using the 90 degree. So by using this sides we need to prove 90 degree. So that is, in a triangle, if squares of one side is equal to sum of the squares of other two sides, then the angle opposite the first side is a right angle. So we need to prove, we are given a triangle ABC, we need to, which AC squared equal to AB squared plus BC squared means we need to prove angle B equal to 90 degree of this triangle. So now construct two triangle ABC and then PQR. For that we need to prove 90 degree, no. So here we are going to use that similarity condition. So just take given in a triangle ABC, AC squared equal to AB squared plus BC squared. So for that we need to prove this one is 90 degree. So now just using a contradict, don't consider this as a 90 degree. Now construct as per PQR. PQR. For that, construct triangle PQR right angle at Q such that PQ equal to AB and QR equal to BC as it is. The same length 5 centimeter means suppose 6 centimeter means here also 6 centimeter. Here 4 centimeter means here also 4 centimeter, like that construct. Okay. Now in the right in that triangle right angle Q so that PR squared equal to PQ squared plus QR squared by using the previous theorem by Pythagoras theorem. Now we constructed PQ equal to AB substitute and BC equal to RB substitute. That is PR equal to PR AC squared equal to AB squared plus BC squared by our construction. We taken only two things. So automatically it's given AC squared equal to AB squared plus BC squared. So substitute AB squared plus BC squared equal to AC squared. So this means AC equal to PR. So we just replace these things only, but it's given as AC squared. So if AC replaced as RP, so RPR. So in this two triangle ABC and then PQR, all the three sides are equal. So already we considered AB equal to PQ and BC equal to QR, BC equal to QR. Now we proved AC equal to PR. Proved. So by the triple S similarity criteria, these two triangles are similar, congruent. If they are congruent, not similar. If we are not proved that ratios, we proved here that sides equal length. So now by using this, angle A equal to angle P, angle B equal to angle Q and angle C equal to angle R. Now already we taken the angle Q equal to 90 degree. So it's here angle Q equal to 90 degree means angle B equal to 90 degree. So we proved by using our sides square. So this one is a converse part of Pythagoras theorem. So first theorem is Pythagoras theorem, second theorem is state and prove converse part of Pythagoras theorem. Right. So for that, construct two triangle as it is. Okay. Next come to that examples in this picture. ACB 90 degree, so angle C 90 degree, CD perpendicular to AB, like that construct, prove that this thing. Now already we know that small triangle to bigger triangles are similar. So ACD, it's similar to ABC. Order is important. AC is opposite side of the 90 degree. So ACD, D is 90 degree. No. Similarly, in this bigger triangle, opposite side is AB. So AB, that is I put in a C. Okay, and by this we can write. Don't change that order because it's important. So if it's a similar, already we have by that the result. So AC divided by AB equal to CD divided by BC and then DA divided by CA. Why we need to consider these two things? Because we need to prove this thing only. AC divided by AB and AD divided by AC. So we need two things. So consider two things. For all things we have AC divided by AB, CD divided by BC, DA divided by CA. So AC divided by AB, AD divided by CA divided by CA. This one considered. Okay. No need this one. CD is not there and BC also not there. So no need to consider this ratio. Consider this ratio. So after using their cross multiplication, because of AC square, no, AC and AC. After finding their cross multiplication, AC squared equal to AB into AD. Next, in a triangle BCD, BC is the opposite of 90 degree. BCD is equal to BAC. It's important, not ABC. BCD, not CBD. Similarly, BCD, it's important. ABC, not ABC, it's BAC. Okay, BAC, not ABC. Be careful, right? After that, we can write the same ratio: BC divided by BA and BD divided by BC, and CD divided by AC. No need. CD is not there. Right. After the same cross multiplication, BC squared equal to BA into BD. So which one we need, that is choose this thing. So here first one, last one. Similarly, we can write here BC divided by BA equal to CD divided by AC equal to DB divided by CB. We need AC square, BC square possible, BC. So choose this two. So choose. Now we need that ratio of BC square by AC square. So divided by 2 divided by 1. So BC square divided by AC square equal to BA into BD divided by AB into AD. So AB and AB we can cancel. So BD divided by AD. This thing we proved. So here just ACD. No problem. ACD. Similarly ABC. Okay, after this rotation. Here we have this thing. After this you can write ABC. Where it's ABC? ABC. Suppose ABC. Okay. So here consider BAC. Important. BAC. So further BCD. This is the important. These two things are similar. Okay. Next problem. A ladder is placed against the wall such that its foot is at a distance of 2.5 meter from the wall, and the top reaches a window 6 meter above the ground. Find the length of the ladder. So picture given. So just it's 2.5 meter above. Here 6 meter height. So now let A be the ladder, that is CA be the wall with the window at A. It's placed here. Now BC is that ground length 2.5 meter. Now its wall consider as right angle. So AB squared equal to BC squared plus CA squared. Substitute that value. 2.5 the whole square plus 36 is 42.65. After taking that square root, 6.5. How to take that perfect square? Just choose from last to 2 digit. Here 36, 42, nearest thing says 6 or 36. So remaining 6.25. So it's doubled to 12. After multiplying 5 we can get 625. So 0. So here 625, here 2 decimal, so we can get 6.5. So the length of the ladder is 6.5. The length of the ladder is 6.5. Next, here in this picture, AD it's perpendicular to BC. Prove that AB squared, CD square plus CD square equal to BD square plus AC square. So think about this thing. AB squared is nothing but right angle given. So AB squared is a hypotenuse. Okay. CD squared is a side. BD squared also side. And next one given AC squared is opposite to right angle. So this thing. So write this thing. So AC squared in a triangle ACD, ADC, AC squared equal to AD squared plus CD squared by Pythagoras theorem. In a triangle ADB or AB squared equal to AD squared plus BD squared. Write this thing. After that, compare by this. We have AD common, no? So AC squared, we have 4, 1, 2, 3, 4, but we need only two things. So for that, AC squared minus AB squared, after subtracting these two equation 1 and 2, we can cancel AD squared. After subtraction, we can get cancel this thing. So AC squared minus AB squared, suppose we can get AC squared minus AB squared equal to CD squared minus BD squared. Now compare AB squared plus CD squared. So this thing we can move right side, this thing we can move left side. So that is AC squared plus BD squared equal to CD squared plus AB squared. So this thing given. So subtract from 1 or subtract from 2, we can get the result. So idea, just use which is hypotenuse, given which is hypotenuse, choose from this, write the Pythagoras theorem expansion and do. Next problem, BL and CM. BL and CM are medians of a right angle ABC. So right angle at A. Prove that 4 times of BL plus CM equal to 5 times of BC. So here all the one is a hypotenuse. So now it's angle 90 degree. So triangles ABC, we need BC squared. So BC squared equal to AB squared plus AC squared. AB squared plus AC squared. Similarly, BL squared equal to AL squared plus AB squared. So here check BL, CM, BC. BL equal to AL, not given, AB. So for that, here AL this thing. So now we get the idea. So AL given, no, this is the half of the side AC. So we can write instead of AL, AC divided by 2 the whole square. That is BL squared equal to AC squared divided by 4. Separate the square. So after finding the LCM, we can get BL squared equal to AC squared plus 4 AB squared whole divided by 4. So choosing the cross multiplication, 4 BL squared equal to AC squared plus 4 AB squared. Similarly, in that CM squared equal to AC squared plus AM squared. In the triangle CMA. For that CM squared equal to AC squared plus AM, no. So for that this is at AM. So AM equal to just 2 times of AM, or AM equal to 1 by 2 of AB. So it substitute AM equal to AB divided by 2 the whole square. That is AB squared divided by 4. Now the same LCM, CM squared equal to 4 AC squared plus AB squared, 4 AC squared plus AB squared whole divided by 4. After finding that cross multiplication, 4 CM squared equal to 4 AC squared plus AB squared. Now we need 4 CM squared and 4 BL squared, no. So add these two things. So 4 is a common number we can consider. Here right side AC squared plus 4 AB squared. So we can get addition of 4 we can get, that is 4 BL squared plus 4 CM squared equal to AC squared plus 4 AB squared plus 4 CM squared, no, 4 AC squared plus AB squared. So AC squared plus 4 AC squared is 5 AC squared. 4 AB squared plus AB squared is 5 AB squared. So 5 is common, here 4 is common, take outside. So that is question. So idea, here just this side BC squared equal to AC squared plus AB squared. So for that median is given, choose this triangle and substitute AL equal to AZ equal to given, or further substitute 1 by 2 of AC. So AC divided by 2. Similarly this side substitute AB divided by 2 and do the problem. Right. Next problem. O is any point inside a rectangle given ABCD. Prove that OB squared, OD squared, OA squared, OC squared just equal like that. For that construct a ABCD. After seeing this picture you can analyze. So just draw the parallel line PQ. Just draw PQ parallel to BC. Now just listen, this PQ is parallel to BC means, what about this angle? So definitely this angle B is 90 degree, angle C is 90 degree. So definitely angle P, no, here should be 90 degree in that rectangle form. So for that PQ is perpendicular to side AB and side DC. So this angle definitely 90 degree. Angle BPQ, similarly angle CQP 90 degree. Now consider BPQZ and APQD are both rectangles. Now in this triangle, because of OB needed to know, so for this consider this triangle. In the triangle OPB, OB squared equal to BP squared plus OP squared, this triangle. Similarly next what we need, OD squared. So OD squared we need this triangle, and OA squared we need this triangle, and OC squared, right? Next triangle OQD. For that first one we taken OB squared, no, next OD squared. So for that OD squared equal to 90 degree, OD squared equal to OQ squared plus QD squared given. Now for that OC squared we need OC squared equal to which triangle? OC squared equal to this 90 degree, OC squared equal to OQ squared plus QC squared. Similarly OA squared equal to just AP squared plus OP squared written, right? Now we need left side OB squared plus OQ squared. So add first this one and second one. After adding this thing we can get the result BP squared plus OP squared, OQ squared and DQ squared. Right. Now we need to prove OA plus OC squared. OA plus OC squared. Compare here. Just OC squared equal to OQ squared plus CQ squared. OQ squared, CQ missing. How can we substitute CQ squared? Just listen. OC square we need. For that OC square equal to OQ square plus CQ square. Now where's our CQ square? CQ is the length. Now this is parallel, no, so we can change this PQ. So we can change this PQ. So PQ squared equal to just CQ square. So one is given OQ square. Now replace where's our CQ? CQ is the same distance to this distance. So change as per BP squared equal to CQ squared. So now change this BP squared equal to CC squared. 1 is over. Another check OA squared. In that OA squared AP squared plus OP squared. OP squared is given. So where is our AP squared? Now it's DQ given. No, DQ is nothing but AP length. So you can replace instead of DQ equal to AP squared. So this is the condition given. So compare by using the right hand side the data, change this BP squared equal to CQ squared as per given. and dq squared equal to change as ap squared as per given. Change this thing. Okay. After that you can replace this one is nothing but ok squared plus cq squared. Instead of this we can replace oc squared. Similarly ap squared plus op squared you can replace as oa squared. So as per the given data you can prove. Thank you.